Now that we have a general idea of the branch and bound algorithm, and we've explored bounding and branching in detail, we can put all the pieces together and talk about the branch and bound algorithm in general. The branch and bound algorithm first focuses on a particular node, and then at this node it's going to compute the bounds at this node, and then after it's computed the bounds, it's going to update, potentially, the bounds of the parent node. After this, if the node isn't pruned, we're going to branch, meaning that we're going to split the feasible region. After we've done this, we've completed with all of the work we need to do with this node, and we need to pick the next node. How to pick this next node is the key feature of a branch and bound algorithm where we have some choice. We're going to focus on two particular ways to choose which node to focus on next. There are at least two different ways to pick which node to look at next. One way is the eager branch and bound algorithm. The other is the lazy branch and bound algorithm. In the eager branch and bound algorithm, we're going to take a particular parent node, compute all the bounds for it, then branch, and then immediately explore a node that we've created in the branching process. So, for example, we started our node P, we branch into nodes P1 and P2, and then the second node we choose is one of the branches. In this case, we've chosen node P1 as our second node. We have the numbers in green associated with how the eager branch and bound algorithm is going to work. And we see that it's going to take effectively a depth-first search strategy. It's going to start at a node, and as soon as it creates a new node, it's going to go deeper rather than wider. We see that the third node is going to be very deep in the tree. The alternative is the lazy branch and bound algorithm. In the lazy branch and bound algorithm, we're going to start at the node P. And then when we branch, we're going to explore all of those particular branches before we look at any new nodes. So for example, when we start at node P, we create the nodes P1 and P2. And we fully explore P1 and P2 before we go into any new node created by the branching process. We can think of this as a breadth-first search strategy. As soon as we create a node, we explore all of the nodes that we've created before we explore any new nodes. We can see again that we've written green numbers associated with the order in which we're going to visit nodes in the lazy branch and bound algorithm. These two different strategies have two different consequences. Although these aren't hard rules, they're just general heuristic rules. In general, the eager branch and bound algorithm, because it gets to such small subproblems so quickly, is going to get better solutions faster. That is, we're going to, in general, get better lower bounds. Alternatively, in the lazy branch and bound algorithm, we're going to get better bounds faster, and specifically we're going to get better upper bounds faster. This is because, as we've seen, to update the upper bound at a parent node, we need to know the upper bound at all of the children node. Because our lazy branch and bound algorithm explores all the children before it explores any new nodes, we can update upper bounds much more quickly.